Hello friends, today we are going to learn about subnetting, and subnetting is very important topic in CCNA routing and switching. First of all, we should know about subnetting. What is subnetting? Subnetting is nothing but we divide a bigger network into a smaller network, that is subnets. That is called subnetting. And the uses of subnetting is, when we use subnetting, we actually saves IP addresses. For example, when we need only 10 IPs and we use /24, that is class C address, subnet, then we are actually using 256 IPs. The valid IPs will be 254, and how many actually we needed IPs? Only 10. So we are wasting 244 IPs in that. The requirement was only 10 IPs and we used class C subnet mask, and we lost 244 IPs. So just to save IPs, we started using subnetting, and so the bigger network will logically dividing into a smaller networks. Okay, that is known as subnets. So before moving ahead, we should know about different types of classes. Okay, that is using IP address. Let's start with the let's see different types of classes and the default subnet mask of each class. There are altogether 5 classes: class A, class B, class C, class D, and class E. Class D is known as for multicast address, and class E is used for experimental purpose. So forget about these two classes. Okay, let us concentrate on first 3 class, that is class A, class B, and class C. Let's see the default subnet mask of class A, that is 255.0.0.0. We also can write like /8. When we say /8, it means 8 bits are on: 1, 2, 3, 4, 5, 6, 7, 8, and rest all are zeros: 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. So 8 bits are on, that's why we write /8, and these bits are known as network bits, and these zeros can be used for host, and hence we call it as host bits. So class A default mask is 255.0.0.0, that is /8. 8 bits are on, that will be known as, this is known as network bits, and rest zeros are known as for host bits. How this 255, that is the decimal number, comes from this? So we'll convert this binary number, okay, into the decimal number. It is very easy. You take like this: 1 into 2 raised to 0 plus 1 into 2 raised to 1 plus 1 into 2 raised to 2, and it will go till 1 into 2 raised to 7. So 1 into 2 raised to 7 is nothing but 128, then 64, then 32, then 16, then 4, sorry, 8 plus 4 is 2 plus 1, and this will be equal to 255. Okay, so this is what we have written. It is in decimal value and this is in binary. So this is called as octet. Each and every which is separated by dot, it is octet since it contains 8 bits. That's why we call it as a octet. So from this it is clear why it is 255, and this goes from 0 to 255. So total it will be 256. Okay, so every octet can go from 0 to 255 and the total will be 256. So hope class A is clear. The default subnet mask and the range it goes from 1 to 126. Class A range goes from 1 to 126. That will be determined by first IP. For example, 10.1.1.1. So from the first octet we come to know from which class this belongs. So this is 10, so this falls in 1 to 126, so this will be class A. Okay, and the default subnet mask we have used of A is 255.0.0.0. so this is class A, and in this we can create 2 power 8, that means 256 networks, and the host will be 2 power 8 plus 8 plus 8, it will be 24. So these many networks hosts we can create by using class A subnet mask. So here 256 networks and 2 power 24 will be the host. Let's jump to the next class, that is class B. Class B goes from 127, 28, 127 will be used for localhost, that is reserved, that you cannot use. 128 to 191, and the default subnet mask will be /16. This means 16 bits are on, and the default subnet mask will be 255.255.0.0. When we write this decimal value in binary number, it will be 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8 0 dot, it will 0 0 0 0 0 0 0 0. So this is the default subnet mask of class B. So here the network will increase. The network will be 2 power 16, and the host will be also 2 power 16. So these many networks we can create, and these many hosts we can create. So always remember, the 1 all stands for network bit, as I told you earlier, and all the zeros will be used for the host. Okay, so hope class B is also clear. The range is also clear. For example, if I write 172.16.1.0, so from the first octet you come to know this is class B, and the subnet mask is 255.255.0.0. So this is class full address, we also say, because we are using the same subnet mask of the IP. For example, this is class B address, we come to know, so we are using class B subnet mask. That's why we say as a class full address. If suppose this is class B address and we are using class C subnet mask, so it will become classless address. This is quite simple. Okay, if suppose, I'll repeat again, if suppose it is class B address and we are using class B subnet mask, then it will be class full addressing. Okay, and if suppose we are using class B or class A's IP address and we are using some other class like class C subnet mask, then it will be known as classless addressing. Let's jump to another class, that is class C. Class C. Class C's address will the range will go from 192.2.2.2.3, and again the default subnet mask will be /24. When I say /24, this means you should come to know that there are 24 bits are on. So 1 2 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8 0.0.0. So this is 255. This is the binary value, this is the decimal, again 255, 255 and the 0. So here there are how many ones are there? Network bits, there are altogether 24. So the network it can create is 2 raised to power 24. And how many zeros are there? 8. So 2 power 8, it goes to 256, and it will range from 2 to 255. Okay, this 0, so altogether it becomes 256. Okay, so from this, hope everything is clear. The range of class A, B and C, the default subnet mask of A, B and C. Okay, so now we'll jump to subnetting, how we divide a larger network into a smaller network, just to save very important IPs which we do not want to get wasted. Okay, for example, we'll go like, for example, in a network, for example, this is a router. Okay, it is denoted like this. Okay, and we connected a switch to a router. We'll give it as a switch 1 and this as a router 1. For example, we need 10 IPs. Okay, 10 IPs. When I say IPs, it is nothing but PCs. Okay, 10 IPs. So I connect 1 2 3 4 5 6 7 8 9 10. Okay, 10 IPs. Out of this 10 IPs, 5 IPs or PCs, I keep it for sales. This is an organization. Okay, let's consider an organization. In that 5 PCs I want for sales, 5 PCs I want for like HR, anything, management you can say. But now here the role of subnetting comes. See, from the 10 IPs, altogether 10 IPs are there, then definitely I'll go for class C, because class C gives me 256 IPs. Out of that, 2 cannot be used. 1 is for network ID and the another one is for the broadcast IP. This we cannot use. So altogether 254 IPs I can use, and this is satisfiable. See here, it can is the requirement is only 10 IPs. We are having 254 IPs. We can directly give class C subnet mask, that is 24. Okay, so from here, but the thing is like, one more criteria is there. The criteria is I do not want this sales to get communicated with this HR department. Now what you will do, if suppose I give sales 192.168.1.1 and the subnet mask will be 255.255.0. okay, this is for sales, one PC of sales, and another of HR consider like 192.168.1.2 and /24, the same subnet mask. If I use, then definitely this will able to ping this IP and can afterwards also transfer, like if suppose I activate FTP, then we can easily get like file transfer can be done. But the criteria is these two IPs should not communicate with each other. And here comes into picture this topic which we are learning, subnetting. The whole network is 192.168.1.0. This is whole one network. Okay, that is 192.168.1.0, which gives altogether 254 valid IPs. Okay, so here what we will do, we can actually divide this bigger network into a smaller one. Okay, smaller one, so that it will create a subnet, two different subnets, and these two different subnets will not able to communicate with each other. It can directly ping to the router, it can go outside whatever it wants. Suppose here is one more router and it is connected to ISP. Okay, it will able to use ISP, but this here management will not able to access sales, not able to communicate with sales. So what was the criteria? 5 PCs was for sales, 5 PCs was for management. What I'll do, we need 5 PCs, right? So when we see 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3. So 2 raised to 3 is 8. So 8 IPs we are getting. Okay, so 8 IPs, out of this 8 IPs, 2 IPs we cannot use. I already told, one IP is for network ID, second IP we have used, it is like by default it is used for broadcast IP. Here 2 IPs is not, so 6 IPs we can be used, and we require 5, so only one is getting wasted. Okay, so what I'll do, I'll give like this 192.168.1.0, and it will go 0 till 7. This will be in one subnet kind of network, one subnetwork, and this whole subnet I will give to sales, and another subnet which will start from 1.8, it will go till 15. I will donate this to the management. And now if I try to ping this .8 to 1, 2, 3, 4, 5, 6, any of these IPs, it will not able to ping, it will not able to communicate, because this falls in another subnet and this falls in another subnet. So did you notice something over here? Here we are using class C, but the subnet mask will get changed. Okay, the subnet mask will be, we are using 2 power 1, 2 power 2, 2 power 3, and okay, 2 power 4, 2 power 6, 2 power 6, 2 power 7. So here these I have like kind of used for network bit. I will make these as 1 till 2 power 3, and rest I will make zeros. So altogether 3 zeros, which gives us 8 IPs, and rest is 1. So for C class by default is 24, and you can add more 5 to it. Okay, so it will be /29. So we are using, if we add all this to the power is 128 plus 64 plus 32 plus 16 plus 8, then it will become 248. So the subnet mask, the new subnet mask will be 255.255.248. This will become the new subnet mask, which will give us 8 IPs, and we can create subnet of 1 2 3 4 5, 2 raised to 5, which will be 32 subnets we can create. And when you will multiply this 32 with this 8 IPs, it will give 256. So let us do one practical on this, and let's see whether it's able to communicate or not. Let me open my GNS. Very simple. You can do this practical on packet trace also. Let us take one router. Okay. And let's do on the packet trace also. So I'll be able to. I'll get switch over there. Let me take this switch, then a switch. Okay, and let us take only 4 different PCs. Okay, and this. Okay. Okay, let's consider only 3. Forget this. This will be like this will be for management, and these 2 will be for sales. It's too fast for you. Okay, let's configure this IPs. We are using this subnet mask. Okay, 9 protocol will come up. Then what we'll do, we'll go to the PC and we'll go to the desktop. We'll configure this 192.168.1.2. okay, and here we'll change 248. okay, and this will give you 168.1.1. let me show you. Okay. Next drop 192.168.1.3 and 248 192.168.1.1, and this will be taking 192.168.1.9. let me take. If suppose I want to ping in my own subnet, ping 192.168.1.2 or 3, it will able to ping its own subnet. But if I want to ping 192.168.1.9 I have given over there, it won't able to ping, since since this is sales and the other one management, I have kept all these two pieces separate. This is like management and this is I have kept for sales. Okay, so this will not able to ping this because I have used the the subnet mask I have used is .248. Okay, and it will go from the block size is 8 and it will go from 0 to 7. Okay, so this IP I have given .2 and this I have given .3. Okay, and this I have given .9. So it doesn't fall into this subnet, it falls in another subnet, that is 8 till 15, this 9. So it will not able to ping this. Okay, so here we are using the network, whole network is same 192.168.1.0. this is the network, but we have divided this bigger network into the smaller one by using subnet mask, different subnet mask. We have carried over some bits from the host. For example, the default subnet mask of class C is /24. This means there are altogether 24 bits are on 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8, but these all are a host, 8 hosts. So what we did, we carried like 1 2 3 4 5 subnet 5 host bits we have carried and converted to 1, and 3 host we have kept, 3 zeros we have kept for host, because we need only 5 IPs and 2 raised to power 3 gives me 6 valid IPs and we required only 5. So hence it fits my criteria. So this is what the main use of subnet mask subnetting, by just carry these more 5 host bits and converted these 5 host bits into network bits, and we have got this /29. Okay, and we have created this huge bigger network into, like earlier it was like 0 till 255, it was one network, but we have made it more smaller one by using subnetting 0 till 7. Okay, 8 till 15, and it will go till 255, 5 to it will go 21, 22 to it will go like 28, 29. So it is like this. So this is what we are doing it in subnetting. Now let's do one thing. Let us like go on internet and try to solve some C class subnetting so that it will get more clear. Let's go to subnettingquestions.com. So this is like, what is the broadcast C? This is the IP address it is given /27. So I'll tell you some tricks. Okay, by using those tricks you can like easily able to calculate the broadcast address of network. So first thing you should always remember, see what they have written over here, /27. So always try to find first the block size. Okay, the block size you can directly slash value, you can directly dilute like divide, 32 are total bits, number of bits, you can directly subtract it from 32, this 27, and it will give to 5. So the block size will be 2 to the 2 raised to 5, and that will be 32. So the block size I have got is like 32. So there are altogether 27 bits are on 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8. So 24, and 3 I have carried over from C, 1 2 3, and rest are 3 4 5 3 5 5 3 8. So these are subnet bits and these are host bits, and this is network bit all. Okay, so I have got the block size which is 32. Okay, so last bits is like mixture of 1 and zeros, so the changes will be in the last bit, because like 27, the 3 bits falls in the last bit, last octet, so the changes will be in the last octet, so it will go from 0 till 31. So what we can do, actually, here is 27. Okay, so the block size we have got 32, the last value is 192. You can directly divide it. If we divide it by 5, then 32 into 5 is 10. Okay, 60, and if we divide it by 6, it will be like 192. 32 is 6, 12, 1, and we are getting exactly 192. So definitely this is the network ID, 172.175. So the block size is 32. If I add 32 to this, I'll get the next network ID, 412.1.224. Okay, so dot 223 will be the broadcast IP of this IP of, or you can say of this network. Okay, see, I have got dot 23, like 223. This is the broadcast address of this particular IP or subnet. This is actually dot 12 is a itself, it's a network ID. Okay, so this subnet we can tell. Let's go to the next question. This is of okay, this is of class C. Let's take some next. I'll first show you all class C, so that it will be good for you. Then we'll jump to the, this is also class B they have used. I'll go to the class. Okay, so this is class C, you can say. So here what we are doing, they have taken 26 as the network bits are 26. So we all know, first of all you have to do 32 minus 26, so you'll get the block size bits, so it will be 6, so 2 power 6 is 64, so it will go from 0 to 63. Okay, so what valid host is the range, so last bit, so 45. Okay, so valid host range, it will start from 172.23.112.1, because dot 0 will be the network ID and dot 63 will be the broadcast IP. Okay, let's see the answer. See, did you get? Hope at least class C is clear from this. Okay, now let's go to see if we are getting some important more. Okay, so which subnet does host this belong, it is asking. Okay, so you can see it is 254, and in the third octet it is getting changed, so we can directly write like this. First octet is like subnet mask is 255, so 8 bits, 1 2 3 4 5 6 7 8. Okay, again 1 2 3 4 5 6 7 8, 254 is there. Okay, so 7 bits are on, 1 2 3 4 5 6 7. So these 7 bits, if you convert these binary bits into a decimal one, okay, so you'll be getting 254. Okay, dot, there are 8 zeros, 1 2 3 4 5 6 7 8, so there are altogether 2 power 9 zeros. It will give you 512 hosts. Okay, and in third octet there are only one zero, so 2 power 1 will give you the block size. And since this is class B address, so this will be the default subnet mask of class B is this /16, so you can't do anything with this, but these 2 power 7 1 will give you total number of subnets, that will be 128 subnets. You can create total 128 subnets, and block size will be 2, and the changes will be over here. The network will get changed over here. So IPs always starts from the right hand side. So let me see what will be the, so the block size we have got is 2, so it will start from 0 to do one thing, 80 divided by 2. Okay, so it will, so from this I come to know that 17 it divides exactly, so this is definitely a network ID. 172.27.80.0 will be the network ID, and this, and the block size is total 2 block size, so it will go 80 till 81.255. okay, so 80 will go 80.0, 80.1, 80.2, it will go till 80.255. again it will change the network bit, and it will go like 81.1, 81.2, it will go till 255. This will be the broadcast IP ID, and this will be the network ID. So which subnet does host? So it is definitely falling in 172.27.80.0. let me check the answer. If I am right or wrong, it will see, it falls in 172.27.80.0. let's take some other question. Okay, what is the last valid host on the subnet? Always try to find out the block size first. Always try to find out the block size first. From the block size, if you find the block size correctly, you will get everything correct. See here what they have written. In the last octet it is 192, this means 2 bits are on. Okay, rest 6 are zeros, that will be total number of hosts, and 2 bits are on. Okay, so this 2 raised to 6 will be the, this will be the block size. Okay, and 64 minus 2, that is 62, will be the valid host. So block size I have got, that is 64, this means it will go from 0 till 63. Okay, and this is in the last octet, so last octet will get changed. And what they have asked, what is the last valid host on the subnetwork? So 63 cannot be the last valid host because this is the broadcast ID, and 0 is the network ID. So broadcast ID minus 1 will give you 62, and this will be the last valid IP of this subnet. So I can write it 172.21.145.62 will be the answer. See, this is the answer. It is very simple. Okay, now let's take the next example. Okay, see what they have asked. They have asked how many subnets and hosts per subnet can you get from the network. So convert this into a slash. Okay, so this they have written as the 248. So 248 means how many bits will be on in this particular octet? 1 2 3 4 5. Okay, this will be 128 plus 64, 224, then it will be like 240 and 248. Okay, 1 2 3 4 5 bits are on, 3 bits are zeros. So from this is class P, these like 255, so there are together 16 plus this 5, so /21 I come to know from this. Okay, but what the question they have asked is subnets and hosts. So the host will be more 8 times 3, 4, 5, 6, 7, 8. So 8 plus 3, 2 power 11. That will be 2 raised 2048 host will be there. But the valid host will be 2046. The host will be 2048, valid host will be 246 minus 2, since one is network ID and the another one is for the broadcast ID. But the valid host will be 2046. Now let's see what they write in answer. Actually they should write host they have told, so they must write 2048. If they ask for valid host, they must write answer as 2046. And the subnet they have asked, how many subnets we can like build through this subnet mask. So there are 1 2 3 4 5 ones are there, so 2 power raised to 5 will be 32. So 32 subnets we can build, and maximum 32 subnets, and host will be 2046 valid host, and host will be 2048. This will be host, this will be the valid host. Let's see the answer. See, 32 subnets they have written. This is what I have done here. 32 and 2046 valid host. They have asked just host. Actually the answer should be 2048. Okay, per subnet they have, okay, per subnet means that means like it is valid host only they are asking. So answer is 2046 valid host. Hope you have enjoyed and also learned some few tips and tricks of subnetting. Okay, thank you very much. God bless you.